Today we're going to be measuring angles and arcs. You should put this one in your journal. I want you guys to understand that we're going to take this circle. We're going to talk about central angles and their corresponding arcs. I want you to understand, first of all, that when I draw an arc going all the way across, does everybody see that we have a straight line right there? That diameter that goes through the center. When you see a straight line, how many degrees is that?
180.
Yeah, 180. So we know that this angle, and this angle, and this angle all add up to 180 degrees. So the very first thing what I'd like you to do, I'd like you to take 6x plus 5. I'd like you to take 5x plus 3 and 8x plus 1. And I'd like you to add all of them together to equal a sum of 180 degrees. Because all of these angles together add up to 180. Good. So I'm going to erase this right here. Come back to it. So how many x's do you have?
19.
19 x's. You're right. You add 6, 5, and 8, you get 19. You add all these up together and you get a total of 9. You solve for x. This doesn't take that long. You take away 9 from both sides. And you get 19x equals 171. And after you divide both sides by 19, you get a value of x known as. Now, wherever you see an x, you need to plug in the number 9. So right here, I want you to plug in a 9. Right here, I want you to plug in a 9. And right here, plug in a 9. Now, as we do this, we're going to be changing, we're working with different colors here. Okay? So that's going to help us find the measure of this central angle. By the way, when I say the word central, what does that kind of remind you of? Something that's in the center, all right? So this central angle is right here in this center. When I plug in a 9, I get 6 times 9, which is 54. 54 plus 5 gets me what? 6 times 9 is 54. 54 plus 5 gets me 59 degrees. I want you to understand, what's the measure of this angle right here? 59 degrees. Now, if I said, what's the measure of this arc? The measure of this arc. If I said, hey, what's the measure of arc A, E, from A to E? You would also say it's 59 degrees. The measure of the central angle will match the measure, now not the length, we'll talk about arc length later, but the measure of the arc. So this matches this. So far so good? Alright. Next thing, 5 times 9 is 45, plus 3 gets us what? 48 degrees. What I want you to understand is this central angle. Does everybody see this little tiny central angle right in here? That's 48 degrees. What is the measure of its corresponding arc? That's also going to be what? 48 degrees. Just like this one over here was, or is, 59 degrees. Last but not least, we're plugging in a 9 and we're going to find the measure of this. Okay? Now, how many degrees is this going to be? 8 times 9 is 72, plus 1 gets us 73. So this angle right in here, the central angle 73 degrees, just like its corresponding arc right here, will also equal what? 73 degrees. Ooh. You got one more thing? Go ahead.
AB is a vertical angle of 73 degrees.
So you're okay. You're right. Angle AQB.
Oh.
That's okay. I see what you're saying. Angle AQB is a vertical angle And if these are vertical angles are always congruent. Therefore, arc, she said arc AB. All right, arc AB, the measure of that is 73 degrees. And would you agree that 73 degrees and whatever we have left, those are going to be considered to be supplementary. What does supplementary mean? They have to add up to 180. So what would the measure of this central angle from B to Q to C equal? 107. Is correct. 107. Which means the measure of this corresponding arc is also 107 degrees. Now, if I say this is the angle, I want you guys to write this down in your journal. Ready? Angle BQC is congruent to 107 degrees. Just like the measure of arc BC is also equal to 107 degrees. So the measure, this is how you write the measure. What does that M stand for? Measure. What is that cool little symbol that looks like it's arcing? Arc. Arc. All right. Thank goodness they made an arc look like an arc.
Why don't they just call it cheating? It's like the same.
Well, but this right here, this is the measure of the arc. This is the angle inside.
Isn't it always going to be the same as the angle?
As long as it's a central angle. Okay, I'll explain. We're going to get into this a little bit later, okay? So I'm going to give you a quick little preview of what's coming up. All right? Here's a quick preview. Ready? If you don't want to see the preview, just fast forward. All right. You guys see this angle right there? So let's say I said this angle was about, let's say it was about 45 degrees. Probably a little bit bigger than that. Let's say it's 45. Then this right here would also be 45 degrees. Well, watch what happens. What if I said, now this angle definitely doesn't match this angle, but it's got a cool relationship. This angle is 22.5. This is still 45 degrees. This is called an inscribed angle. Inscribed angles are always half the measure of their arc. All right? So if that's a 45, that's 22.5. Now here's another cool thing. Watch this. Watch how I connect it. What if I go from here and touch it right there? And then I go from here, touch it right there. You know what the measure of this little tiny angle right there is? Nope. It's also 22.5 degrees. Because you see where it starts? It starts here. Where did the arc end? Right there. So this arc right here is double that number, or that number is half that number. What's always equal? This is a central angle. The central angles always are perfectly equal to their corresponding. But we'll get into this. Let's go back to our problem right now. We'll get into more. This is called inscribed angles. That's our next assignment. Okay? Right. It's really cool. Circles are awesome. So right now, does everybody have all this information? Because right now, what we need to do is we need to zoom out and look at all the problems. Here we go. We're zooming out. So here's what I need. I need help with everybody. We're going to go right here. We had blue. Then we had red. Then we had green. This was also green. And this was orange. So we're just going to fill in some numbers. We already did all the solving. We're going to fill in some numbers. This, I remember, was 59. This was 73. This was 73. This was 48. You just put it on your paper because you're going to need it, right? You need these pieces of information anyway. And this was what, 107? Okay. So now it's important when you solve for these, it's important that you understand that every single one of these, the middle letter represents your vertex. Okay? So order matters. We have to go. We're trying to find the measure of angle AQE. So here we go. We're going from A to Q to E. What's the measure of this angle right in there? 59. Boom. You're done.
Wow.
Okay. Next one. It says D to Q to E. So we're going from D to Q to E.
48.
Oh, wow. That was easy.
Wow.
Okay. C, Q, D. Does order matter?
Yes.
Yes. Start at C. What am I going to go to?
Q.
Q. Go to D.
73.
Boom.
Q.
All right. I'm skipping ahead. Those are pretty easy. Okay, skip ahead. Here we go. A to Q to D. A to Q. Ooh, we're going from A to Q to D. What am I going to have to add together?
59 and 48.
There we go. Take the 59. Take the 48. If I can actually write it down.
What does that mean? That's the opposite of the
Shh. I'm going to talk about that too. You're right. These are right here. I'm going to do it in orange. These are vertical angles. This angle matches this. Got it? Matches this. Okay? So we can add them together, but you're right, Lennox. These are also what? Vertical angles. And vertical angles are always congruent. So there's more than one way to think about it. Either you're adding those together or you're realizing, hey, these match. The sum of these matches the 107. That's what you're doing on problems 1 through 6. If you miss these, you were working really hard but just not doing it. All right? Just follow the order. All right, so right now what we're going to do is we're going to zoom in. We're going to zoom in on this one right here. Zooming in. By the way, there's a piece of information that was given to you on your paper that I can't see because I've zoomed in so much. So in this picture, there's a piece of information you need to let me know.
GPH equals 38.
GPH, so angle. GPH is equal to 38 degrees. So if you would please, on your paper or in your journal, however you're doing this, write 38 degrees here and write 38 degrees right there. Because these are also vertical angles. So this angle and this angle open to their corresponding arcs. These are central angles. So yes, H to G is 38, E to F is 38. Now, we all should know what they are trying to convey to us with that right there. We should all know that that represents what? 90 degrees. So you should know and write down in A. That's 90, just like this arc is 90. Now, that's 90. That's 38. We know that all the way across is 180, right? So we have to just find the measure of this guy right in there. So how much do you think that's going to be?
52.
52 is right. Now, check it out. 52 and 38, what do they add up to? They add up to 90. Then we have another 90, and together that adds up to 180. So 52 plus 90 plus 38, they all add up to 180. Okay? Now, what is 52 plus 90?
42.
Which means right here, guess what? This angle is right in there. 142. Can you guys see that 38 and 142 add up to 180 as well? Which means this corresponding arc that lines up across from the central angle, that arc right there is 142 degrees. And this arc right here is how many degrees?
52.
52. Okay. So everybody, here's what I'm going to do. Now that we've labeled all that, I'm going to zoom out. Okay? We're going to label it again on your paper, and then we're going to go around and figure out the measures of different arcs that are given to us. Here we go. All right, so let's just make this really quick and easy. This one I think was red. This was green. We had a blue. Oh, supposed to be a blue, sorry. Blue and a blue. And then this one was orange, I believe, right? All right, so what we're going to do is we're just going to put things together. We know that's 38 degrees. We know this is 38 degrees. We know this was 90. What was this one right here? 52. And then this one right here was 142. Okay, so we're going to be taking this right here, and we're going to do some easy ones first. Okay, The easy ones are obviously like, what's the measure of E to F? Well,
38.
that's just 38. Now, everybody, any arc that is less than 180 degrees, any arc, that's going to be considered a minor arc. Anything that's greater than 180 degrees is going to be considered a major arc.
So pretty much like chromosomal one is considered a minor.
Okay, I see you're trying to make connections with other things. Okay, just think right now, anything less than 180, minor, anything greater than 180, major. So I see what you're saying. Okay. Now, we're going to go over here to number 12. Read number 12. Check it out. Order matters. What am I starting at?
D.
D. Where am I going to? Then finally to. So it's very important we follow that order. You have to follow that order. So watch. I'm starting at D. Where am I going? So I'm going to G. D to G. Am I done yet?
No.
I got to keep going all the way until I reach E. You see how far I went there?
Almost all the way.
Almost all the way around. So now,
308.
because, I'm just going to go back real quick. This right here, I had to go from D to G to E. You saw I went almost all the way around. So there's two ways of doing it. You could take 360 and take away 52 degrees, which is 308 degrees. Or you could just add, what? 90 plus 38 plus 142 plus 38. Okay? But sometimes it's a little bit faster to do what? Figure out how far you're going around and then just take that number away from 360. That's what I did too. It's a little bit faster. Okay? Now, everybody, let's do one more. D to F to G. Here we go. D to F to G. I'm switching colors on you. See, let's go orange. All right? Where are we starting? D. What do I have to travel to? F. So I got to go from D to F. Where do I have to finish up? G. Wow. So I had to go all the way around.
So 52 plus 38 plus 132.
Or 360 minus whatever 90 minus 38 is. That's what you have to do. Okay? That's what I want you guys to do on these. Good luck. By the way, if it says DE, that's really easy, right? What's the measure of arc DE? 52. You're like, what you don't want to do, listen, what you don't want to do, you always want to find the shortest distance. Technically, you're like, oh, hey, Mr. Mood, I went from D all the way to E. No. Yes, technically, yes, you went from D to E. But major arcs are going to have what? That third, not always. Right? But major arcs typically are going to have 3 letters because they're telling you to keep going. All right? So by the way, you guys see D, G, E, D to G to E? They could also say what? D to H to E. Or D to F to E. Okay? But if they said D, E, F, then that would be going from D to E to F. That would not be the same. All right, good luck. All right, moving on. Everybody, what I need you guys to title this section right here, I need you to title it arc length. Now, arc length is not talking about, say, the measure of an arc. We're talking about the length of its arc, like in distance. Now, we just did an arc length, and I'll kind of give you guys an idea of what I'm talking about. That will come up. Try it again. Hold on, Mom. The compass is not working. Oh. Fine. I won't use your compass. So if we have a circle, okay? The arc length of a whole circle is called its circumference. So 360 degrees around the circle is referred to as its circumference, its distance around the circle, which is pi times d, or 2 times pi times r. Okay? But what if I didn't go all the way around? What if I just went partially around, like that? Okay. What I want you to understand is this is going to be an angle. And we're going to have another part of it right over here. So check this out. What I'd like you to do in your journal right now is we're going to talk about arc length. Okay? We're going to give you a very easy radius. We're just going to call this radius is equal to a 10. I'm going to get my protractor out, see if it'll actually pop up on the screen. It does. Good. I'm going to rotate this around. Let's find the measure of this. Let's say it says 142, but let's make it easy. Let's just make it 140. Okay. Let's pretend that this right here is 140 degrees. What would the measure of this part be? 220. Now, what I'm saying is this. The measure of this arc going all the way around is how many degrees? 220. What's the measure of this arc right here? 140. Now, everybody, if I wanted to find the circumference of this entire circle, all right, then the circumference would be pi times the diameter, all right? And if the radius is 10, what's the diameter? 20. So the answer right here would be 25. That would be the whole circumference. Now, you could also do what? 2 times pi times the radius and still get 25. Now, here's what I want you guys to do. We're going to label it A. We're going to label it B. And right here, we're going to put another point. We're going to call it C. But if I said, I want to know what the measure of arc AB is, like the distance, like the arc length of it, not the measure of the arc, but the arc length. And I wanted to know the measure of arc A, C, B. If I wanted to find those measures, well, that's not the whole circumference, is it? It's a portion of it. It's a portion of the circumference. So this is what you would do. You would take the circumference, whatever the circumference is, and you would multiply it by what you're searching for. How many degrees is this arc? How many degrees? 140. So you take the circumference and multiply it by 140 out of 360. Over here on this one, what's the arc length over here? What's the measure of the arc? 220. So you put 220 over 360. So this is what I'd like you guys to do. Here is your formula for arc length that you need in your journal. Here we go. Write down this formula that you can use at a later date, like tomorrow when you've forgotten everything that you learned today. All right? Arc length is equal to the circumference times the degree of the arc that you're searching for, all right, the degree of the arc, out of 360 degrees, also known as 2 pi r times the degree out of 360. Now, if you wanted to write pi times d times the degree over 360, you can also use that. Okay?
And so
right here, the circumference is what? 20 pi, right? So we would take 20 pi and multiply it by 140 degrees out of 360, and that would give us an approximate value. Over here, for our example problem, you would do 25 times 220 out of,
if it was the plane circumference, so it would be 360 over 360.
Right.
So it would just be circumference times
1.
So you're just finding the portion of circumference.
That's it. The arc length is the part of the circumference. Okay. So that's why I like this formula right here. It just says, hey, whatever degree they've given you, put it over what? 360. Now we have to be careful under problem. Okay? Alright, so here's how you can do it. Alright, we're going to use our examples. Like, for example, what's the approximate value of that 140? You do 20 pi times 140 divided by 360.
Are you recording?
I believe so. Yep. Alright, and then the other one you can do 20 pi times 220 out of 360. So this is the arc length for the 140 degree arc. This is the arc length for the 220 degree arc.
If you want to get like the exact same
then
you just divide it by pi.
Here, by the way, here's what the exact answer. Ready? If you did 140 divided by 360, All right, you hit the math button. See, it's 7 over 18. Okay? So what you have to do is you have to do 20 pi times 7 over 18. So you have to probably use the calculator. Multiply by 7 divided by.
Don't you need to
Hold on. Okay. So you have 70 over 9. The exact answer would be
70 over 9.
yeah.
Alright.
That would be the exact answer. 70 over 4. Right. Stupid 4. Pi. Units. I'll prove it, right? 70 divided by 9 times what? Times pi. See that number right there? 24.43. I'll scroll up. There it is. Right there, 24.43. Okay. All right, now what we need to do, have that in your journal. Moving on to the problem. I am going to do one problem and one problem only. You better be paying attention. Number 16. Okay? We're doing number 16. What are we trying to find the measure of? Which arc?
QRS.
Okay. We're trying to find the arc length of Q to R all the way to what? All the way to S. Okay. So that's what we're trying to find. Q to R to S. Would you agree? Does that right there look a little bit more than 180? It does. They gave us QZS. Oh. They said this is how many degrees right in here. Well, if that's 160.
360 minus 200. 160.
Oh, so guess what? What's the trick? What if students weren't paying attention? What would they use as their degree without needing to? They would use, instead of using what they're supposed to use, which is 200. So here's how you would set it up. The arc length is equal to 2 times pi times the radius times the degree that you need, which is 200 out of 360. Now, if we had a radius, that would be great. I think we've given you a radius of 13.5 units.
Yeah.
Okay? So all you have to do in the calculator, it says round to the what? Round to the nearest tenth. So do I want the exact answer or the approximate answer? Approximate, you're right. So here's what I want you to do with me in the graphing calculator, and then you can do the rest on your own. Get type in that too. I'll go back there. Okay. Alright, here we go. You type in a 2, type in a pi, you open up a parentheses, you type in 13.5, which is your radius. You open up another parentheses, you type in 200, because that's the measure of the arc that you're using, and you divide it by 360. 47.1. And it said round to the nearest 10. So what's your answer for number 16? 47.1, and you would say units.
What's the number for number what?
16, sorry. Number 16.
47.
47.1 units.
Where did it do that?
Because it pays. I think the technology makes sense. No, I don't know. It's probably because I'm standing too far away from the computer and I want to make sure you guys see things from where I'm standing. So that's probably. Alright, so right now, be careful. Just because it says 160, are you going to automatically put a 160 right there? No, check. Make sure. Sometimes you would. If it said, hey, what's the measure of QS or QPS, then that's what you would do. Okay?